When you have two waves on a medium, the waves can travel anywhere on that medium. They could travel next to each other and never interact and be called parallel, or they could travel so that they only ever meet once and move away from each other at the maximum rate. And this would be described as perpendicular. The difference in the path that they take can be described as path difference. In most circumstances, such as the one described previously, it doesn't matter what path a wave takes. But in areas of wave study, such as interference of waves, the journey two waves take is important. Wave 1 travels the straightest path between 2 points. At the end of the journey, wave 1 meets wave 2, which has gone on a longer path and then reflected back, so that two waves meet up again. When the two waves left the source, they were in phase and had the same frequency, wavelength and speed. When they meet again, they are out of phase. This is because the two waves have taken a different journey, and so travelled a different overall length. If they came back together and were in phase, then you could say that the path difference between the path wave 1 took and the path wave 2 took was a multiple of the wavelength of the waves. It doesn't matter which wave, as the wavelength is the same. How far out of phase the two waves are when they meet up again gives an indication of how far the two paths differed. However, you can never work out exactly how far the difference in paths was using this method, as two waves in phase could have travelled the same journey, or journeys that differed by any integer multiple of the wavelengths. If, however, we know the path difference between the two waves, we can work out how many wavelengths and fractions of wavelengths the difference between these paths is, and therefore work out the phase difference of our two waves when they meet again. Path difference is important and studied more when we talk about interference of waves later.